Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, a fix for a very specific failure. The agent that's been asked to do 5 jobs at once and has started quietly falling apart.
That sounds like a war story. Give me the real one.
It is one. A team built a competitive intel agent and crammed everything into a single LLM agent. Scrape 3 sources, dedupe, summarize, score confidence, format the output. The system prompt ballooned into a multi-page spec, and the output started drifting because the model just couldn't keep all those personas straight in its head at once. They split it into a sequence of focused agents, one per stage, and the regressions vanished overnight. Each stage became debuggable on its own.
So this is about giving each step its own clean head. What does ADK actually hand you to do that?
3 workflow agents, and the elegant part is their declarative. Each one wraps a list of subagents and runs them in a fixed shape. The sequential agent, one after another, where the output of step 1 feeds step 2. There's parallel agent, all of them at once, concurrently, and there's loop agent. Run the subagents over and over until one of them says stop.
Declarative. Meaning what? Concretely, how's that different from drawing a graph?
Great distinction. In some frameworks, you build a workflow by explicitly wiring every edge in a graph. Node to node to node. ADK flips it. You don't draw edges, you pick the class that matches the shape you need, drop in the subagents, and the orchestration is implied. Sequential implies the line. Parallel implies the fanout. And you compose them. A sequential can contain a parallel which contains plain agents. So, simple pipelines stay. Simple, but you can still build arbitrary shapes.
Let's make the sequential one real. The classic research, review pipeline. Walk me through it.
3 specialists in a line. A researcher takes the topic and produces 3 to 5 bullet points of real facts. A writer takes those bullets and drafts a 2-paragraph summary with a hard rule. Invent nothing beyond the research. Then, a reviewer checks the draft against the research and responds with exactly approved or revise. Plus a one-line reason. 3 narrow jobs instead of 1 impossible one.
Now here's what I keep snagging on. They're separate agents. How does the writer ever see what the researcher found? It's not like one returns a value, the next one catches.
And you've landed on the single most important idea in the whole lesson. They do not pass return values. They communicate through session state, a shared data bus. When the researcher finishes, ADK writes its output into state under a key, set by a parameter called output_key. Say the key research. Then the writer's instruction literally contains research in curly braces, and ADK substitutes the actual value from state before the writer ever runs. Write with output_key, read with the key in braces. That's the entire contract.
So state is the contract, not the call stack. And I bet that's deliberate. It's not just plumbing.
Exactly. It's a deliberate constraint with real payoffs. First, each subagent gets a focused prompt. The writer doesn't need to wade through the researcher's entire chain of thought. It just sees the clean artifact the researcher produced. Second, the state object becomes your reasoning trace. If the workflow fails, you inspect state and you can see precisely what every stage produced and where it went wrong. And third, swap the in-memory session for a persistent one and the whole workflow becomes resumable across runs.
Okay, the parallel one. When do I fan out?
When the subtasks are genuinely independent. Picture 3 researchers, finance, legal, market, each digging into its own corner, each writing to its own state key, all running at once. Then a synthesizer reads all 3 keys and merges them into one brief. The pattern is parallel for the independent digging, then sequential for the merge step at the end.
And the trap. Because I can feel one coming.
You should. Parallel is only safe when the agents don't depend on each other. The instant the legal researcher needs to know what finance found, it is not parallel anymore. It's sequential. Force parallel onto dependent tasks, and you get incoherent merges. where the synthesizer is left papering over gaps because the pieces never saw each other. The rule of thumb: when in doubt, go sequential, measure the latency, and only then decide if parallel is worth the complexity.
Last shape. The loop, that's the one that runs until satisfied.
Right. The canonical use is a drafter-and-critic pair. The drafter writes an answer. If a critique exists in state, it revises to address it. The critic reads the draft and either says exactly stop or hands back one specific improvement. They cycle. Draft, critique, revise, refining against a quality bar until the critic is happy.
What stops it from cycling forever? A critic could be impossible to please.
And that's the danger the lesson hammers on. Always set max underscore iterations. A critic that's too strict or a drafter that simply can't satisfy it will loop forever and just incinerate your token budget. 3 to 5 iterations is typical for refinement. And here's the diagnostic. If you find yourself needing more than that, you don't have a quality problem. You have a prompt problem. Cap the loop. Then go fix the prompt.
So with all this power, when should I actually reach for a workflow instead of just one agent?
And this is the discipline that separates good engineers from over-engineers. The test: don't build a workflow until a single agent demonstrably fails. Workflows cost you N model calls instead of one. So more latency, more tokens, and N prompts to tune instead of one. They earn it only when roles genuinely differ. A writer wants a different style than a critic, or when you need auditable, checkpointed stages, or when a refinement loop is truly the right shape. If you can describe the task in one sentence with one tool list, use one agent, and stop.
So the one sentence to carry out?
Split into a workflow only when one agent breaks. And when you do, remember the subagents talk through shared state, not return values. State is the contract.
Perfectly put. That's the Datarekha audio guide. Catch you in the next one.